Hello, folks. Welcome to Rational Science. I hope you can see me okay and hear me okay. Please let me know otherwise. Anyways, as I've been saying for the last couple times, I'm on the road. I was in a little town and did not have good transmission quality, and so I had to abort last Tuesday. I'm sorry about that. It's just the way things are. Anyways, let me get started with, let me first listen to see if anyone can hear me and see me, okay? Okay? Okay, can you hear me, see me? Please let me know. I want to make sure that everyone's okay. Okay, thank you. Anyways, I'm going to start with extinction. Okay, we had this gentleman, and he's a professor, college professor, and he has some bad news for all of us. He says the global economy apparently is going to be in deep trouble in the coming months. Okay, his opinion, but he's been credited with predicting previous collapses or depressions or whatever. And here he is. He said his name is Nouriel Roubini. He's known as Dr. Doom. He always brings bad news. But he went from being a Cassandra to a sage. In other words, Cassandra was a lady who was able to foretell the future, but the gods determined that she would not be believed by anyone. And so Rubini was some kind of Cassandra. Now he's considered a sage, a guy who knows what he's doing. And he says the following. He says, global financial markets should brace for a period of decline that will be more severe than the crashes of the 1970s and 2008. Okay, central banks will eventually give up their monetary policy tightening before inflation is ever defeated. Recession, financial crisis. That's what he predicts. He says stocks are down more than 20%. Inflation is not going to fall fast enough. When you have negative supply side, you get a recession. Okay, we're not going to get it to get a fall in inflation that's rapid enough to go to 2%. Okay, and the result of all this will be a period that combines the worst of 1970s and the global financial crisis. This is just the beginning of that pain. Wait until it's real pain. Okay, and he says you have a major financial institution that may crack globally, not in the U.S. maybe now, but certainly internationally. Okay, so yeah, I think the global economy is in trouble. Okay, the American economy is in trouble, and I think that's the main one. If that one goes down, forget about everything else. But if the U.S. economy is in trouble, the global economy is in trouble, and we're all in trouble. So in that sense, I agree with this gentleman, who apparently travels quite a bit, and he says you got to see countries firsthand. You cannot talk about just statistics. You got to go and see what's going on in each country, more or less. Okay, so I had a few comments regarding extinction and the global economy in relation to the global economy. And this is what we see. It says pretty straight up mechanism, that fellow says. Crops fail globally and we're pretty much toast. Okay, looking at the fertilizer crisis, you know it's getting close. Okay, and some of that has to do with the fact that Ukraine and I think even what is it? White Russia and Belarusia um, are producers of quite a bit of fertilizer in the world and distributors. It is more like putting in more money and getting out no food. Okay? So it's not no money, no food. It is more and more money to make sure there will be less of everything, but more weapons. Okay? And we deserve extinction, he says. Yeah, deserve is an opinion. Again, we try to stay away from politics and opinions. But yeah, I think we have a problem with no money, no food, but not in the way he put it here. I just want people to understand what the theory is. And the theory is not that we're going to have problems with fertilizers or that, somehow that's going to create hunger out there in the world. I just want people to understand the theory. The theory is that money will disappear completely from planet Earth. There will be no money because no one will accept money, because everybody will see money for what it is, which is an abstraction, first of all. Second, no one will accept it because it will be devalued to such a point that there won't be any point in having bills or dollar bills or money in the bank, checking account, a number in your bank account, or cryptocurrency, or even gold. You give someone gold, the guy says, well, that's a rock. What do I do with it? And you say, give it to someone else, and nobody else wants it. And so not even gold or diamonds or anything like that will have any value. I'm saying the global economy collapses. By that I mean that money will be no more. No one will accept money because money will have no value around the planet. That's the theory. Okay, money will collapse. Okay, that's what I'm suggesting. Okay, FL says here, says, all empires fall. Fiat money always continues. Intelligent people are thinking about evolving past fiat money that's becoming more and more of a control system. Okay, that second paragraph there, or sentence there, that's a political statement, okay? Some people believe that, no problem. But I'm concerned about that first part, whether fiat money always continues, okay? The issue is that, and also about that other statement, empires fall. The United States empire will fall, I think, when money collapses. I think the United States empire, the American empire, will be the last empire. There will not be, in my vision, in my plan, the way I see it, there won't be a Chinese empire that replaces it. The United States will not allow China to surpass it militarily. Okay? We've learned too much from history to allow that to happen. Okay? So I don't think the United States will allow that. That's one issue. But the other one is whether fiat money will always continue. And the first thing you have to understand is that in the Paleolithic, we had no fiat money. There was, we didn't trade shells, even though some people do argue for that, some paleontologists or so-called paleontologists. They say there was money, there was trading. Hunter-gatherers, they just killed whatever they were going to eat, fed their families themselves, that was it. No trading. And so at some point we created money of different kinds throughout the ages. And to say that money will continue forever, I don't think so. I think at some point, money, which is the currency that we use to trade, it doesn't matter what money you trade, okay? But I think money will disappear, and it will not be replaced by anything because you will not accept anything. You cannot say you're going to accept brown money instead of green money, for example. We changed the money or the method of payment. Instead of, gold, you went to bills, and from bills we went to cryptocurrency, whatever. At some point, we're going to run out of ideas, and the fact that we use all these types of monies does not guarantee that money itself will have no value because too much debt, governments producing too much money to cover holes, and at some point in time the system collapses, and who do we go to after that? Do we go to heaven and say, hey, give us more money? What for? I mean, at some point money will have no value, and people will realize that and will not accept money, and that's why money collapses. Money we use to pay salaries so that people can spend that money and stimulate consumption, and it's just a cycle. And when that chain, that currency that we believe so strongly in disappears, that whole system collapses completely, disintegrates. So I don't think money, fiat money, or any kind of money for that matter, will continue forever. We created it, we invented it, and we're at the end of the line as far as, inventing more types of money. And it's not a question of creating more money, it's just a question of saying, what value does money have after a while if you're devaluing the coin every day and paying ever less real value to the workers, which are supposed to spend that money so that you stimulate consumption and wheel keeps rolling. That's what the issue is. So I think money will collapse. We will not believe in money. In God, we will not trust anymore, right? Okay, another fellow says, it's a good theory, the money collapse, right? Counterpoint, some archaic species do survive, sharks and crocodiles. Okay, he says that some species did survive in the past, and so not all species are affected. That's what his argument is here. Humans are classic omnivores, so it would require a systemic ecosystem collapse, which seems unlikely absent some kind of catastrophic cosmological type event. Okay? A systemic global economic collapse is certainly a possibility, but that then becomes more of an analogy rather than a replication of what happened to the dinosaurs. Okay, so let's understand the theory. The theory is that food disappeared. You can call that an ecosystem collapse, but it did not require some kind of catastrophic event, in the sense of, by catastrophic I mean a sudden event. Okay? Species were disappearing towards the end of the Cretaceous, towards the end of the Triassic, Jurassic, Permian. Species were already disappearing way before the end of the era or epoch or whatever. So it's not like they disappeared all of a sudden at the last moment. Okay, hadrosaurs, for example, they were around for quite a while, and you can see that the number of species were dying before the end of Cretaceous. And a catastrophic event such as an asteroid strike will not produce that effect. The other issue, which is more important still, or more fundamental, more basic, it's that you cannot produce with a catastrophic event the extinction of old species versus new species. In every single instance, every single one, no exceptions, okay? We had the old species die, the ones that had been around for a long period of time, the dynasties that had been around for a long time, those were the ones that went away. And the new animals, the tiny animals that now could expand and occupy new niches, new vegetation, those were the ones that radiated. That's what we see in every mass extinction. So that's what you got to explain. You don't only explain selectivity, which is one issue, but also chronological selectivity. Okay, and you can't do that with a catastrophic event. So that's the issue. That's the main issue against catastrophic events. And the most famous one, obviously, in the case of the dinosaurs, was the asteroid strike, alleged asteroid strike. Even if we concede that assumption, it doesn't tell us how some species that were around for a long time died, and while the new ones, in this case, the mammals, and together with the angiosperms, expanded. In fact, I showed that last time. I'm going to show it one more time, and here it is. This is the Cretaceous terrestrial revolution. Okay, and you can see just by the chart that the number of species of angiosperms multiplied, while the cycads and other conifers of the Cretaceous, the food that I suggest that the dinosaurs ate, were disappearing. It's the angiosperms that muscled aside all the other plants. Not so much that muscled aside. The correct thing is that way of looking at this is that the cycads and the conifers were already on their way out. They had run their cycle. Specifically, their genetic diversity went away, and it was time for them to go. Okay, so they were not reproducing at the same rate as the other plants, the angiosperms. And that's why the angiosperms expanded. Who expanded with the angiosperms? The mammals, which ate angiosperms. Even to this day, we do not eat cycads or conifers. We do not eat ferns. We eat angiosperms. Okay? Any herbivore eats angiosperms. Okay, another fellow says the problem with historic data, it's an unknown. We don't know how many species existed, how many extincted. I don't think we need to know. It's not important at all. The numbers are not really that important when you look at theories, but yeah, you could include it in there, but it's not a requirement to know how many species there were. We know some species which were extincted due to human behavior, like the thylacine and other endemic creatures. First thing you have to know that thylacine did not die because of man. I just pulled out one sentence out of a paper out there. It says the thylacine had become locally extinct on both New Guinea and the Australian mainland before British settlement of the continent. In other words, humans did not kill the thylacine. Okay, you could say we kind of left them without a garden, an island, less land for them to be in. No, the last few thylacines, I think, just whittled away gradually, even without man. And we could have, we did kill one thylacine at the last moment, and this one, I think, was the last one, was it died in a zoo over there. And so, we did not really kill all the thylacines and got rid of them. They were already on their way out. And you can see, or you can maybe imagine one of the reasons for that, and that is that the thylacine was a marsupial. It's a tiger, kind of like a dog, like a wolf, that's got a pouch. Now, if that ain't an old species, I don't know what is. Yeah, the thylacine was on its way out. That's all it was. Okay? Kangaroos were still around, but the thylacine, he had gone through the cycle. And yeah, humans could have, at the last moment, muscled them aside, kind of crowded them out. But we were not the cause of the extinction of the thylacine any more than we were of other species. Okay, so that's my take on that. Let me show you the last comment here. Paul says, have you considered what is referred to by scientific researchers as the Adams event? Okay, New Zealand tree rings over 40,000 years old revealed a planetary magnetic pole reversal. And essentially all he talks about is that the magnetic pole reversal, that the Earth turned on its, North Pole to South Pole and vice versa later on. Does it supposedly every 26,000 years. And so he says that is what I call a physical mechanistic explanation for past and future mass extinctions. The problem with that, again, I'm going to keep insisting, you got to answer the question. And the question is, how do you explain with that chronological selectivity? I mean, even if the Earth turns around, assuming every 26,000 years, and I don't care how often that happens, first of all, that number doesn't tell you what happens after millions of years. That's one issue. You would say, well, if the Earth turns around on its head once every 26,000 or even 50,000 years, that does not explain why some of these species did not die earlier. You would have new mass extinctions every 50,000 years, and that's not the case. That's one issue. The other issue is that even if the Earth turns around, okay, so what's the explanation? So the magnetic pole is reversed. And so what? What are we going to say with that? How did that kill the animals? And how did that kill the animals selectively? Because what you got to explain is selectivity. And more than that, you got to explain chronological selectivity. Why do the older animals die and the new ones continue? That's what we see in the record. You don't have to take my word for it. Just go out there and look at the different epochs, right? Triassic, Jurassic, whatever you want to look at, and you'll see that the animals that died had been around for longer, much longer, than the ones that survived and continued on to the next epoch that radiated with a new vegetation. Because vegetation also became extinct. And so you got to consider the vegetation together with especially the herbivores and the carnivores that survived by, preying on the herbivores. Okay, let's move on to the subject of today, which is the Higgs. Okay, what is the Higgs? Well, it's known as the God particle. And here's one of the gentlemen who I think baptized it as such, the God particle. Okay, here it is. His name is Leon Lederman, and he's, or he was, he died a couple years ago, and he was a Nobel Prize winner. He called it the God particle because it was like the particle that would tell us how mass comes into being. And they were looking for this particle for many years. And apparently, the argument is that they were successful. Okay? And someone got a Nobel Prize for doing that. Okay? And so the question is, this God particle, what is it? Well, apparently it produces mass. It creates the mass that subatomic particles have. Okay, so if they didn't have mass before, thanks to the good old Higgs, it does have. They do have mass. Okay. Okay, so here we have a gentleman who it's named after. His name is Peter Higgs. Okay, also won a Nobel Prize a couple of years ago because of his discovery. And we find that he wasn't the only guy around who knew about the Higgs. It says in the 1960s, Higgs proposed a broken symmetry in electroweak theory could explain the origin of mass of elementary particles. This so-called Higgs mechanism, which was proposed by several physicists beside Higgs, which makes you kind of wonder why he got the prize and not others, right? If they all came up with the same idea, predicts the existence of a new particle, the Higgs boson, the detection of which became one of the great goals of physics, therefore the God particle. Some people got upset with that name, okay? And continues here, says the Higgs mechanism is generally accepted as an important ingredient in the standard model of particle physics, without which certain particles would have no mass. Higgs first became interested in mass, developing the idea that particles, massless when the universe began, acquired mass a fraction of a second later as a result of what? Interacting with a theoretical field, the Higgs field, right? Higgs postulated that this field permeates space, giving mass to all elementary subatomic particles that interact with it. Gluons that bind quarks together confer most of the particle mass. Okay, so that's the general idea, and apparently Higgs was credited with coming up with this Higgs field, so I guess he's one of the guys who won the Nobel Prize because of that. There were a couple others, even though there were apparently many people around the planet who had the idea of the Higgs already in their heads. Okay, so here we have a couple guys who explain it in probably more down-to-earth language so that layman can understand. Here it is, okay? Says we have these two bosons, the bozos. CERN scientists Dave Barney and Steve Goldfarb explain the Higgs boson, okay? And they start out in their video, there's a YouTube video on these two guys, elementary particle that has no structure. That didn't sound right in my ears. You know, what do you mean a particle that has no structure? What does that mean? It means it has no shape? I mean, you know, I have no idea, because if they say, look, it has no parts to it, is one thing. But to say it has no structure, that also suggests or insinuates it has no shape. So that word structure would need to be clarified quite a bit. But then they continue to say, when a particle passes through the Higgs field, it interacts and gets mass. These are their words, but all these are their sentences, their statements. The more it interacts, the more mass it has. So here we have this particle that's interacting with the Higgs field, right? The more it interacts, in other words, I guess the bigger, the stronger, the massive, more massive, or whatever you want to call it, the more it interacts with a field, the more mass it has. Okay, that's the general notion. Okay, and it says the Higgs boson is an excitation of the Higgs field. So we have two things here. We're saying what these people are saying. On the one hand, they say it's a particle that interacts with a field. Then on the other, they say that it's the same field that interacts with itself because it's the excitation of a field. So we have, it's like water interacting with water in an ocean. Okay, we have a wave interacting with the ocean, so to speak. That's more or less the sense that they want to give you. And the more the wave interacts, the more mass it has. Meaning it's going to encounter more resistance. That's essentially the notion that Higgs and all the people who believe in the Higgs boson are talking about. They're saying, look, if it interacts more, or it feels the field more, then it's going to have more, the wave that hit the rest of the ocean is going to have more mass. That's essentially what they're saying. And so they have the field interacting with the field because the Higgs boson is a vibration of the field itself. Okay, I hope you understood all that. We have a wave of the ocean interacting with the ocean, and the bigger the wave, the more massive it is. That's essentially it. But until it interacts, until there's an interaction, some process going on, some phenomenon, some motion, until then, it has no mass. It has mass only when it interacts. Okay? And so it says, by finding the Higgs boson, we know that the Higgs field exists. That's how they proved the existence of the field, because if they could find the boson, they knew the field exists because the boson has to interact with the field. And they finally say that if there were no Higgs field, the world wouldn't exist at all. Man, Jesus, thank God for the Higgs field. Otherwise, we wouldn't exist. Nobody would exist. Okay, so this is more or less the notion. I'll put it up here, illustrated. We have all these fish, and you can also consider them as waves or whatever you want to consider them as and they're swimming against the river. So they encounter resistance. And I guess the bigger the fish compared to the smaller fish, the bigger the fish, the more mass it has. And the smaller the fish, the less mass it has. Okay? And yeah, I illustrated it this way as well. Okay? Here you have the Higgs. Mass is all these smileys. They're not smiling very much. And they're moving against the field. And it's their motion against the field that causes them to have mass. And then allegedly, this is transferred to particles as well, to other particles as well. Okay, so they are the ones that, one way someone explained it is assuming you were a person in a crowd, okay, and you try to move through the crowd, kind of the bigger you are, the more you vibrate or whatever, you encounter more resistance because you hit more people in the crowd. Whereas if you're skinny and you don't move as much, you don't vibrate as much, well, then you have an easier time to go through the field of people. So that's more or less the notion. But there's a little bit of problem. That's what I want you to think about, okay? If it's true that mass is a function of an interaction between the boson and the field, right? And that's what conveys mass to other particles, assuming even to the Higgs itself, then mass is a dynamic process. Okay, let me repeat that. What these people are saying is that there has to be an interaction. The Higgs boson has to interact with the field, and we're going to forget the notion that the Higgs boson is something different than the field, okay, or similar to the field, or it's the field itself. But let's forget about that. Let's assume it's a particle. So this particle is like something separate, discrete, all on its own. It's going to interact with the field, and the more it interacts, the more it vibrates, the bigger it is. Any way you want to conceptualize that, that interaction is what conveys mass to itself and to other particles. Okay, so it's got to be an interaction. There's got to be a verb in there, dynamic, motion. Without that, you have no mass. And that notion kind of contrasts with what you'll see next, okay? And it is, what is mass? So let's start there. Let's find out what mass is, what this particle of mass is simulating. You know, what concept, what thingy is this mass? Okay, that's what we're trying to get to. Okay, so we look it up and go to the Wikipedia, a good source, because a lot of people write in there, and that's the one everybody anyways consults most people out there. So that's the notion that the laymen have out there. And of course, if the scientists or physicists or mathematical physicists would object to that, they would have changed that, anything that's wrong in the Wikipedia anyways, okay? And so here it is. You go to Wikipedia, it says, in the physical science, okay? In physical science, one may distinguish conceptually between at least 7 different aspects of mass, or 7 physical notions that involve the concept of mass. They have, you could say, 7 different definitions of mass. They don't have one definition that we can sink our teeth into. They have many, okay? Several. Okay, that's not a good starting point. So what is mass? Well, you look it up in a couple other sources. Respectable, always respectable. And you find this. Here's Northwestern University says, mass, how much matter there is in something. Well, how much matter, how many atoms, how many particles, any way you want to look at it, that's different than what we just heard from these other people saying that mass is an interaction between the wave and the ocean, the particle in the ocean. Anyway, you want to see that as well? Okay. We have 2 different notions of what mass is. Is mass the quantity of particles, of units, of balls, of grains of sand? Or is it an interaction between the grain of sand and something else, the field? Those are 2 different notions. They don't match, these 2 notions, these 2 definitions. And again, the Eric Weinstein's World of Physics, another prominent site, says the quantity of matter contained in an object. That's what mass is. Well, quantity of matter is very different than interaction. Quantity of matter is, I have 12 marbles in my bag. That's a quantity of matter. That's different than saying that the marble, hits against something and produces the so-called mass concept. Okay? And just in case, we go to find out what weight is. Why? Because weight is an interaction, okay? Apparently, according to mathematical physics. And here you see it. It says several definitions exist for weight. Again, many definitions for mass, many definitions for weight. Not all of which are equivalent. Obviously, we have 7 different or several definitions of weight. Obviously, they cannot be equivalent. And it says there, weight of an object, the force it exerts on its support. So for example, you have there a scale, you put a ball on it, it's going to push the scale downwards, that we call that the weight, okay, whenever it stops. And so that's the weight. It's an interaction. Weight, in that sense, is an interaction. And that's different than quantity of matter, than saying I'm going to put 10 balls on the scale. Or no scale at all, just 10 balls. 10 balls being mass, how much mass the 10 balls have together. Well, it's a 10-ball mass. That's what it is. Here, this is different. This is how much one ball pushes on a scale, an interaction. Those 2 are 2 different notions, completely different. So I guess when they talk about the Higgs, they're talking about weight and not about mass, because they're saying that the ball is going to interact with the field, right? And that's going to be the result. The result of that will be mass. That's called weight, not mass. Okay? We're talking about weight. Mass is something else. Mass is quantity of atoms in the ocean. That would be mass. But weight is the interaction of one ball or particle or whatever with the ocean. And the interaction is weight. And here they're suggesting that what the Higgs is not the particle of mass. It seems like it's the particle of weight. Okay? And here we have it as a physics fact, just in case, confirmation. Weight is independent of the object's state of motion. Now we have a contradiction, because right now they said it's an interaction. Now they say it's the, and you have to have something moving. And now they say, no, you don't have to have anything moving. And doesn't consider any contact force. And that's because they never saw the, or felt the mediator of gravity, of mass, right? Of whatever confers mass upon a particle. That's why they say there's no contact. We say there is contact. The contact is through the electromagnetic rope, so they are in contact. We just can't see or touch that mediator. That's different than saying there is no physical contact. Okay, but it says when the particle, photon, right, is at rest, its relativistic mass has a minimum value called the rest mass, which in the case of the photon is known as zero. The mass of the photon is considered to be zero. Okay, so as long as it doesn't move, whatever that is, because the photon is always moving, allegedly, the light never stops, then it's got rest mass. But as the particle, the photon, right, is accelerated to ever higher speeds, its relativistic mass increases without limit. Well, we got a little problem because now they're not talking about interaction. They're just saying speed. They're just saying the particle is moving away from something through, I guess, empty space. It's not interacting with anything. It's just going faster, faster, and faster. The faster it goes, it has more weight. In fact, more mass, they say, which is what? Quantity of particles. So I guess the photon is acquiring more particles as it moves along, or is it that it's pressing harder on the scale that's going to measure it? What is mass? What is weight? What is the difference between mass and weight? These people keep going around in circles. They say that mass, in the case of the Higgs, right? Mass is an interaction. Then they say, no, weight is an interaction, the ball with a scale. Now they're saying there has to be no interaction for weight. The particle just has to travel faster, meaning if there was a scale there, you could gauge, how much pressure it causes. And without that, they just say the faster it goes, the more it weighs. No interaction whatsoever necessary for that to happen, which has nothing at all to do with the quantity of matter, which is the definition of mass. So we went full circle around. We don't know if we're talking about weight or mass, whether the Higgs is a particle of weight or of mass, and we will never know because they've never defined mass or weight. They have 7 definitions for mass. I don't know how many they have for weight. So we have no idea whatsoever at all what these people are doing out there. And just in case, we throw the icing on the cake, here it is. These are Wheeler and Taylor, 2 so-called physicists, mathematical physicists, and they clarify for us everything that you ever needed to know. Okay, here it is. They say nature does not offer us any concept as the amount of matter, mass, right? History has struck down every proposal to define such a term. Even if we could count number of atoms or by any other counting method try to evaluate amount of matter, that number would not equal mass. Okay, so after all this said and done, we have no idea what mass is, what weight is, or whether the Higgs is a particle of mass or of weight. What is the Higgs? It interacts with a field. I thought that was weight, when something interacts or pushes against something, against the scale. And they're saying mass allegedly is quantity of matter. And now they're saying mass is actually not quantity of matter, it's an interaction. Okay? So we're not talking about how many atoms, we're saying how much one atom interacts with a field of some kind, an ocean or whatever, some fluid, I guess. So we have a contradiction there. They have not decided what mass is or whether this Higgs is a particle of mass or of weight. And the final point here is that we look it up in the standard model of quantum mechanics, okay, and we find a Higgs. And so if you ever wanted to know what the Higgs looks like, well, it looks like, apparently, for what I can see there, it looks like a ball that's got an H on it, like Harvard, an H. And that's the Higgs. It's got all these little numbers there we don't care about, we just want to know what it looks like. And I guess it looks like that, like a ball with an H on it. And it's a ball that has no mass until it interacts, which means it's the particle of weight. I don't know, you tell me. Okay, that's it for the Higgs. Let's move on to our science critic. He made a video, 45-minute video, criticizing the scientific method. Unbelievable. And today he's going to talk about what he accuses me of doing, and that is using word salad known as semantics. He says, I'm challenging the scientific establishment using semantics, whatever that is. Okay, so let's listen to him so we know what the subject matter is today, what his argument is. Here it goes. Give me a second, and here goes. The issue I address in this rebuttal is this fellow apparently believes that defining words scientifically amounts to petty semantics.
You know, in Bill's efforts to use semantics to try and undermine current science, he should really read the definitions a bit better. Now, if I had to guess, it's probably because he wants to say that modern science is irrational. Look how irrational it is. Look at the definition of an object.
Okay, so these are the concerns, and these are the questions I put before you for you to ponder. You chew on them, see what you come up with. These are my criticism of his criticism. Okay, here it is. Does a scientist need to define terms in order to communicate a theory? You know, if I start saying X, Y, Z and I don't define X, Y, Z, do you think you'll understand my theory? Or do I need to clarify what X, Y, Z mean if I'm going to use those words in some kind of dissertation? Okay, so that's the first question. Second issue, if you challenge a definition that makes or breaks the speaker's theory, right? Are you engaging in petty semantics? Okay, yeah. So if you challenge someone, say, look, what do you mean by God, for example? What do you mean by space-time? What do you mean by black hole? Is that and even if the guy tells you what it is and you challenge that definition because you say it's an irrational definition, at least you challenge what he's saying, his notion of it. Is that just petty semantics, or is it getting the foundations of physics straight? Okay, that's the issue before you. Third issue, if the presenter treats the concept mass as a physical object, for example, right, and begins to move it around during his dissertation, right, is pointing this out to him a semantic argument? Okay, so here's some people, like we just saw, using the word mass. And they say mass is an interaction. And you say, well, hold it, what do you mean mass is an interaction when these other, your colleagues here, or the dictionary or whoever, defines as the quantity of matter. And now you're saying it's not the quantity of matter, it's the interaction of matter with something else. Well, those are two different notions. I need those clarified. I need those, organized in some way that I can follow your presentation. Is pointing that out to him a semantic argument, saying, oh, this is just petty semantic word salad, word wizardry? Or is it goes to the root of what he's trying to theorize for you? Okay? And the last issue is the definition of the sine qua non word object. Remember, this is what was at the root of his complaint, right? Used by mathematicians when they provide physical interpretations, the main one being see and touch, because they define it as that which has matter or is made of matter or whatever, but that's not the one they use. The one they use is see touch, because they're going to go to a lab and they want to see and touch whatever they consider to be an object, a thing, right? And if that's the one they use, is it, if it's unscientific, if it's irrational, meaning that, for example, you need two objects to be able to produce touch. You cannot see an object that's on the other side of the universe. You don't see one on the other side of the earth, let alone on the other side of the universe. So not all objects can be seen, not all objects can be touched, especially those that you imagine. So if you imagine a tree or a rock, is the word rock an object? Is the word tree an object? even though you can't see or touch the one I'm thinking of. So if it's an irrational, pointing that out to the person who's giving the presentation, is that a semantic argument, a petty semantic argument? So these are the questions that you should think about, okay? And all I can do is point them out to you so that you ponder them on your own. I'm going to tell you what to think. I'm just telling you what the questions that pop in my mind, okay? Okay, let's move on to the questions and comments people made since last time. Had a lot of them, so I'm just going to go through a few of them. Okay, here goes. First one says, what are your thoughts on Timothy Morton's hyperobjects? Some weird physics philosophy concept. Well, I looked him up. I didn't know who he was, so I looked him up. Morton uses the term to explain objects so massively distributed in time and space as to transcend localization, such as climate change and styrofoam. Okay? Not very physical. I think he was dealing more with politics. He continues, this is out of the Wikipedia, by the way. Morton's theoretical writings include the cultural significance and context of food, ecology, and environmentalism, and object-oriented ontology. In metaphysics, object-oriented ontology, OO, right, is a 21st century school of thought that rejects the privileging of human existence over the existence of non-human objects. Object-oriented ontology maintains that objects exist independently of human perception, much like we covered in the past, Kantian noumena. Okay, so this is what this fellow Morton, Timothy Morton, proposes. They call them philosophers. I think that has nothing to do with philosophy or physics or science or nothing. It's just politics. That's all it is. They create concepts that have nothing to do with anything, and they call it what? Object-oriented, whatever, ontology. And here it is. So we look it up. What is a hyperobject? Well, these are some characteristics, okay? 5 of them. It's viscous, it's molten, non-local, phased, and interobjective. First one, hyperobjects adhere to any other object they touch. Okay, great. Hyperobjects are so massive that they refute the idea that space-time is fixed, concrete, or consistent. Non-local, hyperobjects are massively distributed in time and space to the extent that their totality cannot be realized in any particular local manifestation. Phase, hyperobjects occupy a higher dimensional space, whatever that is, right, than other entities can normally perceive. And it says, continues, hyperobjects would appear differently if an observer could have a higher multi-dimensional view. And the last one, interobjective, hyperobjects are formed by relations between more than one object. In other words, he's not talking about physics. What we're talking about here are just concepts that this fellow created, I guess because they ran out of topics to deal with, and so they create these new concepts. You know, you have the mathematicians, they create the mathematical objects, and these people created the what? Object-oriented ontology. Ontology meaning what exists out there. It's got nothing to do with anything. And the second thing is that, just keep in mind that physics is the science of existence. Only physics deals with existence. It has a monopoly over that. Anyone touching the word exist, or talking about what exists out there, you know, ontology, maybe philosophy as some call it, he crossed the line into physics, okay, whether he knows it or not. Okay, another fellow talks about see touch here. Says a material thing that can be seen or touched, okay, that's the notion we have out there, or the mathematicians have out there of what an object is, see or touch. And he gives an example. He says, if you see a laser beam, is that material? And the answer, he says, is no, okay? Because he says you can't touch it or see it. He's right about that to some degree. We can't really touch it, but what he may not be aware of is that light is, if it's like we propose a rope, that's the assumption we made. and it's connected to every atom, in his finger, every rope is connected to every atom in his finger, then you are touching, in a sense, a light. Okay, you just don't see or feel it, but you are touching it whether you know it or not, because it's not like two separate things touching. It's like one becomes the other. It's like, in that sense, it's continuous. So in that sense, you could say it's not touching, but there is a connection there. But otherwise, he's right. It's you can't base what an object is on the basis of these two criteria: see and touch. Okay. Here's the next one. Fellow says, prove a God and a devil. It does not need to be combined with science. In science, especially in physics, we do not prove anything, specifically the existence of anything. We don't prove the existence of a table. We do not prove the existence of God or of the devil, or deny the existence of God or the devil. Okay, this is not a question of opinion or of belief. It's a question of let's define the word exist. So we do not prove. What we do merely is define the word exist, and there you have it. Exist, physical presence. Physical refers to an object, and presence refers to location. An object that exists is one, and only objects, concepts cannot exist or be said to exist, not in science, not in physics, right? Which holds a monopoly over the word exist, okay, for rational discussions. To be an object is not sufficient. It must have location. Once it has location, distance between it and other objects, then we can say it exists by definition. So it's not a question of belief. It's a question of defining the word exist so that we can use it consistently, meaning scientifically. Okay, so yeah, if God or the devil one exists, first they need to be objects. They need to be things. And as long as you treat both God or the devil right, as things, you started on the right foot. And the next one is they have to have location. And if they do have location, they both exist by definition, pursuant to the definition. Okay, here's another fellow. He put a comment here and he says, I think gravity is confusing because it is two separate scenarios. Okay, there is the tension version, A, and then there is the pull version, B. Okay, we have pull versus tension. Tension is a static concept, as we've discussed in the past. Okay, no one wins the tug of war. Pull does. Pull, someone has to win the tug of war. That's why pull is a force, tension is not a force, except in mathematical physics. Okay, a ball on the table is under tension, but not being pulled. Okay, well, it is under tension, no doubt about it, because it's not, assuming it doesn't move a bit, it does have weight. There is gravity, what we call gravity, acting upon it, and what we say it's being pulled, which is the wrong word. In that sense, he's right. It's just being held there by the ropes that are connecting every one of its atoms to here on Earth with our planet. Okay, that's the issue. Okay, no problem. But then he says that remove the table and now the ball gets pulled down to the floor while still being under tension. The answer is no. It doesn't get pulled down. Okay, that's why gravity is not a pull force. If we come down to to the nitty-gritty, to really understand what gravity is, we are saying that as the ball falls, it has different weight at different locations. More weight the closer it gets to the object, in this case the Earth. What's happening is all the ropes fan out. There are more independent ropes acting upon every one of the atoms that form the ball, and that's why the ball falls down. It's not being pulled. We have to forget the word pull. We use it quite a bit. I use it too. I want you to know that. But when you put me against the ropes, against the wall, okay, I will clarify that there is no pull. What's happening is more and more independent ropes that were before on the same axis now are acting on separate axes. That's what it is, okay? And so he says maybe it would be useful to give them different labels rather than calling them both gravity. For example, gravity for A and gravitational attraction for B. Well, yeah, that's a question of wording. All I'm saying is we should forget the word pull for gravity. We have this notion that gravity is a pull force. There is no force, there is no pull. What it is the object at different locations closer to the Earth has greater and greater weight because the ropes fan out. All the ropes that connect every atom of that object to every atom of the Earth, they all fan out and act at different angles. That's what it is. Okay, and the closer you get, the ball gets to the Earth, the more ropes that fan out. Okay, here we have another one. There is definite reason for gravity. Well, hopefully. There has to be, and not reason, the word is cause. There's a definite cause. Reason we use for philosophy. I am convinced that I know. Okay, I am convinced. He pats himself on the back. I'm convinced I know. Okay. That gravity is caused by push factor. Okay, he's one of those people who proposes push gravity. And he's not the only one. There's a lot of people out there that think gravity is a push force. Okay, there is reality in shadow theories of gravity. Okay, and that's the Lesage type mechanism where it goes all the way to Lucretius, by the way. And that is that people think that gravity is a function of this shadowing, that if you put something in front of something else, it creates a shadow effect. And because the object that is moving is protected by this other one, then it's being pulled or pushed at a stronger force. And the issue there is there's no shield that you can put for any object in the universe that you can create that is like a gravity shield. If an astronaut has some kind of shield in front of him, the gravity for some reason goes right through the shield and pulls, and we'll use the word pull, both on the astronaut and the shield at the same time. So you cannot put a shield in front of you to protect yourself from gravity. Okay, so yeah, like I say, gravity is a function of not a pull force. What it is the object has more weight at when the distance between the object and what is falling towards decreases. Okay, here's another fellow along the same line. It looks like we have a gravity day today. There is a mechanism for push gravity, okay? You just use pressure of all of the objects to push out and contract space around all of the objects locally. Okay, we're not going to get involved into all the details. I just wanted to address the fact that he says contract space. Space is nothing, that which doesn't have shape. It's a concept. Space is not a thing, okay? Space is nothing, okay? It's nothing. You can't contract nothing. You cannot contract, physically contract that which is not an object, that which is a concept. So that's all we need to address in what he raised there. So as long as you can change that, maybe we can talk about your push force or whatever you think it is, gravity is. And another fellow, he says, the smallest viable measurement of time is derived from the unit of distance called the Planck length. Okay? It is impossible using the known laws of quantum mechanics and the known behavior of gravity to determine a position to a precision smaller than the Planck length. Well, I don't know, I can conceptualize something small. I mean, count to 10 and I'll think of a number less than that. Okay? You can say, name any number you want. You can say, look, 55, I'll say 54, and I beat you. And any number you want to think about, I can think of a lower number. Okay, you just tell me what your number is, and I'll beat you every day of the year. Okay, and so the same with length. Just give me the Planck length, I'll divide it in half, and I already beat you because I can imagine something smaller than the Planck length. I don't have to measure it; I only have to conceptualize it. Okay? And then he says, there's no way to go below the Planck scale in terms of distance or time. Yes, it is. I just divide it in half. Divide the Planck length in half, and you'll be okay. You'll find out that you can get as low as you want. Divide Planck length by 1,000,000, and you'll get even smaller pieces of Planck lengths. Okay? Now, whether they're out there or not doesn't matter. What matters is that I can conceptualize something smaller than the Planck length. It's where dimensions become so tiny that the classical laws of physics break down and quantum effects kick in. Okay, yeah, again, we don't care about any of that. None of that has anything to do with physics. Okay, it's got to do with math. And once again, I can conceptualize anything smaller than the Planck length. Just give me the Planck length, or give it to Atom Man, and he'll cut it in half and give you half a Planck length. Okay? And finally, we got the last fellow here. He talks about motion. He says, I have trouble accepting the idea that motion is eternal in the way it was discussed here. With existence, I follow the logic in that if it's not eternal, we are stuck with creation ex nihilo. Okay, yeah, I mean, you can have creation. If it's not eternal, it had better be created. Okay? But he has a different version of what motion is or how motion started. He says, however, I don't see motion as having the same problem if we can let go of the notion of a primary mover. Well, yeah, I mean, that's the issue. The issue is that you cannot let go of a primary mover because you need something to move whatever you're going to move for the first time. And that means that wasn't the first thing to move. You now have to revert to the primary mover and find out how it started moving. You know, all these like Augustine and Saint Anselm and all these fellows in the old days, you know, they were talking about the primary mover, meaning God. And so they just suggested that God set everything in motion. Not only did he create the first objects other than him, if God is a him, he created objects other than him for the first time, and then he set them in motion. He's the primary mover, or the prime mover. And so the question is, yeah, well, you can't do without the prime mover for motion, for the origin of motion, any more than you cannot imagine the popping into existence of an object all by itself. You know, I think we all have to agree that we would need a God to do that, a magician of some kind. And then the question is, you know, is he eternal, or how did he come into being? Okay, so we have to explain the God as well, how he came into being, how he began to move. Okay, and so if you get rid of God, well, I think it gets worse for the people who propose creationism. Mathematical physicists, general relativity, quantum mechanics also, because they talk about particles coming in from the void. And if you're going to postulate that and say, look, the particle came into being, it started moving for the first time all by itself, well, you know, I think most people would say, well, I'd rather have God and just have him wave the magic wand and put it into existence and into motion, right? Then we can all deal with that a little more. Then we can fight about God later on, but at least we know that we can understand how the particle came into being and how it started to move. We need that prime mover, prime creator as well. So yeah, he wants to get rid of the prime mover. He says, let's assume there is no prime mover. Well, yeah, I mean, that is the whole issue. So he didn't really conceptualize anything. He said he had trouble accepting the idea of eternal motion. And yeah, in the case of the rope model, we say that motion has always been there, or everything has always been moving, let's put it that way. And at the same time, every object out there always existed. Why? Because you cannot have space spontaneously acquire length, width, and height and turn into something, and vice versa. You cannot have something that has length, width, and height, a three-dimensional object, lose its dimensions suddenly and turn into absolute nothing, empty space. So unless you can tell us what the mechanism is, You cannot say, well, I don't know how that happened, but that it did happen. That's what I believe in. Well, your belief is irrational. That's all you can say. Okay? Because if you cannot explain the mechanism, you cannot say that you're going to believe in that simply because you want to. You can take that into your church, talk about it over there, but not into science, not into physics. Okay, folks, with that, I hope to see you next Sunday, okay? And hopefully I'll be back in Frankfurt by then. I'll stop my rambling and my